So first off, I would like to invite uh, Pierre Pelletier to speak on behalf of Nuvoola. Pierre, welcome.
Thank you. So I am French, so sometimes I might speak fast and I might use some not necessarily always the best words, so please bear with me. We're going to talk a little bit about our technology. We work primarily, or since the beginning, in the last 8 years, we work with smaller ports as sandbox to then grow and grow, and now we're growing into bigger ports now. So a good place to bang your head, make mistakes, get better, get more efficient through the process. And so 7 years later, now we've got a very, very precise and something that Anne would talk about a couple of weeks ago. We were just getting prepared and talk about it was saying, okay, well, Pierre, try to narrow down, a couple of words that best describe Nuvoola. And I could honestly tell you I had a hard time being French also, but I was trying to precisely get 5 or 6 words. But if I was to narrow it down, I would say non-intrusive, productivity, precision. And so we're real time, we're non-intrusive because we most of the time use existing data, so data from different sources or data creation using cameras. So we're our computer vision. So we use a lot of cameras to be able to extract data or extract specific information and then classify that data. And once we have that information that's classified, then we can push or pull that into different systems. So I'll show you a couple of videos that will give you a good idea. But in the port context is level setting the field between the different systems. So from the time of transportation, when you're coming in for appointments or coming for a rendezvous or your time to come to the port, our system is waiting for it to come, but then we validate and we then fast track coming in through gate access control. So this is all an automated process using cameras, being able to extract data, and I'll show you that as well. Then through the gate into the yard or into the different terminals, and vice versa, coming from the vessel itself, the unloading from trains as well as with trucks and trailers. And so we will talk so often about visibility. So giving you real-time visibility. And how do we do that? Well, we have developed a platform called Luke. And Luke stands for Learn, Understand, Know, and Execute. And it's made up of multiple different functionalities to be able to extract certain data to make intelligence with it. But the beauty here is that it's able to understand what it sees and be able then from there make a specific decision. And so I'll show you a little video here that will go into that. It'll show you quite clearly what I mean. But we're really about giving you greatest visibility in real time, integration, be able to speak between different systems, and then for sure all to do with what we would call fluidity or efficiency in your operations. So think of Nuvoola as kind of a AI, artificial intelligence systems that glue between the different systems that push or pull data with different systems, and also what would replace a human being in terms of validation. So always to think about as before, so it actually we help to organize or prepare or ingest the data coming from the planning perspective coming in, what's happening in real time at the gate or at the wharf or at the train logistics center, and then all that data is then now classified and then be able to be used to different systems. And it's non-intrusive. So most of our truckers, most of our people that work on the cranes don't even know what's happening. We're extracting the data and then we're creating digital files or digital evidence and registrations from that. So if you look at it here, from the reservation system coming into the gate, automated gate process, and then come through the process. So this is a little video and a really extract, and I can show you really all the details of that. So as it's coming in, we're pulling the license plate logo. We have a trick question to say, what is your purpose here? We validate a driver with an RFID card, and then we're asking specific questions. And this is now pulling this information in real time. So we went now, which usually takes anywhere between 5 to 10 minute check-in to 20 seconds. We have a digital evidence. Once we have all the information is correct, it's been matched and validated. We open the gate. We then look at when it's pulling out. We do a 360-degree inspection of the vehicle itself, comes through, and we have digital evidence in a fraction of a second. So that you just saw a full check-in. That check-in took all the registration with digital evidence, looked up the actual bill of lading itself, then looked up the scheduling system, dynamically assigned that driver to door 8 and went to door 8. And then we follow it through, and then we continuously track it also depending on our field of vision in cameras within the site itself. So that in itself, that's kind of very, very quickly, that's our site. But the beauty is this, is that we're able to extract data from using cameras that don't even, it's all, and the truckers love it because it's very efficient, but all this information now is digitized, and now we can now push or pull that information anywhere you like. And so apply this also to train, apply this also to our vessel in terms of your rate of unloading or loading. We've perfected that in different ports throughout Canada, and now we're looking to expand in the US. This is all to do with, so what is the business benefit to this? It's all the check-in, check-out process, making sure that somebody doesn't leave with the wrong trailer. But I often talk to, part of the people working in the shutware or logistics with the locomotive or rail cars, saying, have you ever lost a container, or you ever couldn't find a truck or trailer, or you couldn't find a trailer? This will never happen here with our system. And it just automatically comes and it's digitized, so it's being able to communicate with all your different modes, either on telephone, laptop, etc. So this is what our newest version. So we've gone through 6 different prototypes. Now this is our newest one. Where actually you have paperwork where you scan the paperwork right at the teller. So it's a fully unmanned process where you're taking all the information, you scan your paperwork, and then we direct the driver. We also work with trains. So as I was speaking about, we have what is called our train shipment visibility. Same principle. We're extracting data from using cameras, pulling the information that feeds into your dashboard. What's nice about this is that it's actually able to look at speed. It can pull out also dangerous goods. Dangerous goods in Canada and the US, it's hazardous materials. So all the different UN numbers, etc., being able to extract that data and then be able then to classify that data, and that's the beauty of our system. Now the benefit here in Canada US border is that now we have a manifest, a train manifest, and we're able in real time to be the single source of truth, where we'll be able to compare. It says, well, whatever you have on your manifest that's heading to the border, we just say, well, this is the exact train that just passed. And so a lot of the business benefit we have with our clients is that they have their manifest, and then we are now, because they can have huge penalties, and so we're able to marry that information that's digital and say, no, this one here is wrong, it's not in the proper sequence, or it's the wrong hopper, it's the wrong reefer, etc. So we're recreation of the train in real time, and then comparing that to the paperwork, and then they have a specific amount of time. They have a couple hours before they arrive to the border. They can either stop it at macadam and change the configuration of the train, or change the paperwork, which they most often do. So the beauty here is having that data. The data is being extracted, is classified, and then you can measure anything. You can be able to look at all different types of how much time it takes, what time of the day it takes longer, who of my couriers are most performant, and then also looking at overlay that information with accidents, congestions. So there's a lot of all the multiple use, and not just in terms of the fluidity and efficiency, but also looking at prevention within the operation. So yeah, I guess I would finish off, and I know I did that very quickly, but I know I'm actually perfectly on time here, which is very rare. But it's all around, it doesn't really matter all this extraction of data, how now that information is being fed into different systems, and to be able to integrate into the overall system that creates the fluidity we're looking for within a part. So it's very important. That's our raison d'être. That's how we built ourselves, is that we were able to extract data from all different types of multiple different sensors, IoT devices, and different systems, and also then or create that data using our digital competencies, and then be able then to communicate that throughout different systems to create that fluidity in the operations. That's it.
Merci, Pierre. So you were incredibly efficient with your time, and I just invite the audience to keep track of your questions and can ask each of the presenters in the breakout room after. Pierre, if you'll unshare your screen, and Sylvain, if you'll go ahead and share your screen. Next up will be SimWell. And I'd also like to invite those in the audience to please stay through all the sessions, because as you're going to see as we are presenting, that there's a nice tie-in on how all of these different solutions can be applicable, in some ways even compatible with each other, or offering different views, not from real-time analysis to more predictive analysis to more of the modeling tools that are available for thinking about full systems. So with that in mind, Sylvain, if you
Yes,
would like to
absolutely.
please share your screen, and welcome back from Las Vegas. So Sylvain
Thank you.
and Braid Theory, our team met with our Canadian partners at the Manifest Future of Logistics and Supply Chain Conference in Las Vegas earlier this week. So it was a great opportunity to really dive into the weeds in the U.S. Logistics sector. So Sylvain, without further ado, why don't you go ahead and start?
Absolutely. And the only thing is, I don't see the button to say presentation mode on top of my screen.
It should be within your own slideshow. Just go to the from the beginning within your own part there. There you go, and you should be fine.
Well, here we go. Thank you very much. So, well, good day, everyone. My name is Sylvain Gazai, and I'm the Chief Operations Officer at SimWell. So, who is SimWell? Well, we are a modeling and simulation firm. We initiated our team in Canada, and we are now located in Canada, United States, Australia, and India, and we're looking at expanding in Europe next year. We've got a team of about 70, 75 people and growing, and we've got a multidisciplinary team essentially that help our customer building simulation tools to help them address their most complex challenges. So we do some simulation, we do some optimization. We use our simulation models with our optimizer, and we implement them and integrate them into real life operations, which is what people refer to as a digital twin. Now, just very quickly, for those that don't understand what simulation is really, is at this point in time, a lot of people are actually, they have specific problems to address. And what they do is they sit down with their teams, they brainstorm, they come up with a few ideas, they use Excel spreadsheet, they calculate, and they make decisions, they adjust, they have a solution. They observe what's going on in real life, and then they realize that, oh, all right, the solution may not have been as perfect as we thought. They adjust and they start again. What simulation is essentially is, instead of doing that, what we do is we come in and we work with our clients to actually duplicate what is happening in real life via a model, a simulation models using specific software. And we verify, validate that this is a true representation of reality. And then once that model is validated, we can actually test 1,000 different scenarios and possibilities. We can run what if scenarios all the way to what we believe will be the optimized solution. And at that point in time, you can actually implement the best of those solutions in the real world. So therefore, saving a lot of time, a lot of money, a lot of potential capex investment that you're going to realize may not have been the best optimized solutions, and that way you can become more efficient, more effective. So one example of a simulation model that helped tremendously one of our clients. The client was thinking about doing a $5 million investment to add some rails to a system to their network, because they thought they didn't have the capacity to actually increase throughput. By building the simulation model and optimizing their schedule, their train schedule, we were actually able to add one more train per week to their operation. And basically, one train means $52 million per week times 52. Sorry, $1 million per week times 52 weeks, $52 million, and avoiding a $500 million investment to change their infrastructure. So those are the kind of savings that you can look at when you're talking about using simulation models to help you optimize decisions. I'm going to have four very quick examples. The first one that you see on my screen right now is it's a warehouse. I'm going to start the model, and you're going to see that you have trucks that will start arriving at unloading docks and loading docks, and then you're going to have the forklifts that are going. You're going to have different product types identified by different color schemes and different areas as well. Now, if you take a look at the bottom, and I'm just going to pause it for a second, if I can. There you go. You see toggles at the bottom. So what we do is we create a nice user interface for our clients to be able to create scenarios very easily. So in this case, you can increase your number of forklifts, decrease the number of per unload truck time. You can truck capacity. What if your truck capacity, you've got bigger trucks? So you can actually change as many toggles as you want, and therefore run your model. You can actually run your model and compare. Oh, sorry. You can actually run your model and compare the results after you run one run to the next, or you can actually observe as you are changing your toggles. You can actually observe your results as it is impacting your operation. Just going to move it up a little bit here because I just want to get to the. You can see it in 2 dimensions as well, but you can actually take a look at your processing time, your utilization rate, your queuing, your orders, anything that you want. This is a live model. So you can see your orders that are in queue or that are being assembled. And obviously, you can actually make a very, very informed decision of your operations as they are unfolding. The next model I want to show is, just one sec, there we go. This model here is actually a global supply chain. So with this type of model, our clients, that specific client was looking into figuring out, where do I put my next warehouse? Where do I put my next distribution center? And the kind of questions you can answer with those models is you can figure out your inventory levels. You can figure out the number of trucks that you need, the number, in this case, there's no rail. And then you can actually compare also expenses level and cash flow and sales versus your CapEx and OpEx cost as things are progressing. So very useful model again for these kinds of decisions. This next one is obviously a shipyard. In that specific example, our client was looking into comparing different technologies, different types of trucks to move sea containers, different types of forklifts. At the back, you can see there's a crane also that's going. And they also wanted to know what happens when you actually have a train arriving with a bunch of different other product types. What's the impact? Do I need more trucks? Do I need more forklifts? How do I want to optimize my operation? So you can actually verify and validate your shipyard the way it is today. Then you can start making some changes, and you can actually test as many options and alternatives as possible. And this is the type of model that we actually used for allowing our customer to actually add 1 train per week to their existing schedule. The last model I'm going to show today, and we've got tons and tons of models, but it's basically the transportation via sea. So you can see you've got like your ships traveling around the world. And in this specific case, the client was, we wanted to reprioritize his ships if there was a storm, or divert ships to different locations instead. So that tool allowed our client to actually optimize his shipment of goods to allow, for example, ships to arrive on time at ports and minimize the amount of time that it's going to take to load and unload your ship as well when you get to your ports. On this slide, I'm going to drive your attention to the left of the screen where the solution is. The reason why I'm doing that is because you can use one model for different potential users. So if you take a look at the dashboard as an example, If you click on the dashboard is going to give an operator a view of his her operations as they are unfolding in front of them. So it's like a big board of with warnings and things that are red if it needs attention because something is not working properly. But you can also have the daily planner that wants to re-optimize a schedule because something happens, such as a storm or such as there's an accident on a road. Re-optimize my routes for all of my trucks on the press of a button. 15, 20 seconds, you're going to have your re-optimized routes right there on the spot. A manager may be more interested into evaluating different types of CapEx investments. So perhaps before automating certain aspect of his operations, he wants to compare the inclusion of different types of technologies to pick the best ones. Or at the bottom, the user management, HR. HR may want to do some workforce management to try to figure out I'm going to have an increase in demand in about a month from now that I'm predicting. How many employees am I going to need? So you can actually plug resources as well in those models and answer those questions and therefore be better prepared. So the solution that we give will give you what's going on right now, what will happen the next 24 hours, what will happen in 2 weeks, 2 years if you want to, and run as many what-if scenarios as possible. So now, with regards to the green shipping corridor and where SimWell comes in is we believe that we can actually build a full model of the entire green corridor value chain. We call it the integrated logistics value chain for the shipping corridor. Whereas we would create a model that would go from the port of Shanghai, port of Singapore, for exit entry point at the gate to the port of Los Angeles and the port of Long Beach as well, exit and entry point. And what we would do is we would have a higher level model that would actually follow shipments throughout the entire corridor, and you would have all of the models that I actually showed you connecting to that higher level model. And that's where we dissociate ourselves from anywhere else. It hasn't been done yet. We've done it. We've done portions of it in the mining industry, but we're gonna need to work together to actually be able to achieve that. And that and the connection of those all of those models together. As you can see, the issue is that there's a lot of different players in there. So how do you make this happen and work together? But at the end of the day, everybody can actually benefit. You can actually test somebody's decision, like somebody's ideas, and test what's the impact on everybody. So that everybody, it's a win-win for everybody in that are included in the value chain. And the one thing as well that I would like to point out is a lot of people believe that they have an optimizer, but all they have really is a live view of what's going on. They have like a really good understanding of the data that they have in front of them. But an optimizer is actually a mathematical equation that comes in and actually improves your system by looking at millions of different possible connectivities and leading to the best potential solutions. And this is what our experts do at SimWell. So for me, for SimWell, the next steps is, I believe, from a green shipping corridors perspective, we need to identify all the stakeholders that need to be part of those solutions. We also need to identify all the technical solution providers. And as an example, Nuvoola AI, they're fantastic at data capture. We're not. We will rely on Nuvoola AI to capture the data to feed our models. There's another partner of ours, Sentient. They're located in Australia, and for them, they are expert at modeling, at model coupling and execution. So essentially, the ability to connect the different model types together. And now we're going to need some CO2 expertise as well. SimWell is not an expert necessarily in CO2, right? And there are other models that we may want to actually include. Sorry for my French here. Meteorological models, sea state models, air quality models for different cities, right? We don't SimWell does not make those models, but there are people who build those types of models that you want in your integrated value chain. So yeah, in terms of the next step, I think we're going to need to assign a leading modeling simulation consultant. Is it SimWell? Is it somebody else? We need to figure this out together. What about funding, right? Potential funding, sponsors. How are we going to fund that, right? Is it the cargo owners? Is it the governmental, through governmental grants, the shipyards, perhaps the BDOs? And my last point, the real benefactors of the CO2 reductions is companies like IKEA, Ford, GM, Toyota, and many more. So in order to start perhaps with something that is manageable, not to blow it out of proportion, perhaps working with one of those at first to try a solid proof of concept, and after that grow to other product types, and include things like stockpiling, dangerous cargoes. You know, you add complexity to your models and whatnot, and eventually you have a fully integrated value chain that's going to bring value to everybody. So this is all I had. Thank you very much for your time, and I'm looking forward to the question period later.
Thank you, Sylvain. If you go ahead and unshare your screen. So for those of you in the audience, and of course, again, we're recording this so that we can share it with those that were not able to attend today. But I think as you're seeing is the companies that we're working with to bringing over, it's not really just to sell existing systems, but it's also to see how do you expand, look at new opportunities, expand the technology, find more collaborative partners and opportunities. And also, as Sylvain was, setting up a straw man there for what comes next. We're looking at across the board of all the different players, the green shipping corridors, but also just looking at decarbonization of goods movement and the shipping sector in general, and ports, terminal operators, the BCOs, all the different players. We're going to start to need looking at system of systems. And so this is some of the conversations that were happening this week with SimWell, and we invite all of you that are attending this call to really become a part of the conversation. Again, both of these companies have been very open and understanding that the individual solutions that they bring need to be integrated with legacy systems, with future systems, with thinking about how everything fits together, which is part of why we're coupling all these solutions today, so that you start seeing that there are different pieces of the puzzle to solve big hairy problems, as some people like to say. So now, without further ado, I would love to invite RunWithIt Synthetics to join. And Myrna, you'll be presenting today. So please go ahead and share your screen, and look forward to the conversation.
Thank you, Anne. And yes, I think thanks, Sylvain, for that presentation. I think there's a lot of less words that I need to say now, because we are truly in that world of being able to dial forward and optimize futures as well. RunWithIt is relatively new to the world of ports. However, we have been working for the last 5 years in the cities that connect to your ports, and I'll go through a little bit about that today. But we are in a similar world of SimWell, in that we have created synthetic twins of regions all around the world, and our passion and our purpose and how we are being utilized is to really help build and plan those strategic futures, especially ones that involve unprecedented conditions and circumstances, technology, policy, infrastructure, climate, but that also involve the human-centric side. So something that's oftentimes left out of engineered environments, or even can be a decelerant when it comes to activating change. So we're going into our 10th year this year and have a really diverse and dynamic and accomplished team in a variety of disciplines. We are founded from Canada. We have done business around the world, and we also have a sister company out of Delaware and an office in Seattle. So we are international. We have been, our technology as well as its applications have been involved in a variety of sectors, everything from hydrogen to decarbonization. We won a global call with the United Nations, but also a lot of critical infrastructure work around energy security and critical infrastructure security planning and its connections to some of the new demands, especially around decarbonization. This is why, as Sylvain was saying, why these technologies, I think, are really gaining traction is many places have really profound emissions targets, and they have a certain number of key existing technologies under consideration as well as anticipated technologies. They're also operating in new environments. So in the Inflation Reduction Act has connected some very strong targets and policies and even regulations in terms of infrastructure environments for many industries who use or utilize the ports. They have to report on social and environmental justice. There's expectations for communities who may be adjacent to ports, as well as in terms of participating with the ports around those. And engagement has changed too, and the expectation of engagement through the process, which can be complicated and don't always have the tools to be able to facilitate that. Coordination and collaboration is critical. So understanding, not only, is it one port, but ports need to make some changes in lockstep. And some very high-level strategic changes need to be understood and played out and understood in terms of data and impact and timing. And that data is a problem. So oftentimes data, even inside organizations, we work with a lot of regulated industries as well. They have data, but the data they have is siloed or protected, or it's missing, or it's biased, or it's historical in its nature. So the relevance is not entirely there, and that these pose challenges when you are trying to use data to support decisions, some really important investment decisions. And so like SimWell, this is the platform that we have been operating from, is being able to create a Google Earth, except a version of it that's living, so it has populations and movement and mobility and transportation and critical infrastructure, and then be able to manipulate or sandbox new things under consideration. So unlike very detailed models that SimWell is constructing or building, RunWithIt looks at larger scaled models that involve even communities and community aspects, or energy infrastructure and how utilities interact with ports. Whether they're considering hydrogen or electrification, what infrastructure needs to be in place and when, and then policies that incent that, policies that are being interpreted. Strategic OEMs are using our environments to also look at and mitigate their risk in terms of how they advance their technologies in relation to regions such as ports or transportation corridors. For us, we are a generative AI company, so we produce forward-looking data or future data from the models that we create. Being able to see is really important, so we also focus a lot on dynamic visualization. So like similar to the models that SimWell was showing, that being able to see, we can interpret a lot of things visually that we can't always see, or it takes time to see numerically or in terms of graphs. And so we focus on that especially for stakeholder groups that involve diverse stakeholders. And then augmentation. So oftentimes the data that's missing, we can build models that will produce that data. We can augment data, so our models dial forward and create can be inflected with new scenarios or optimizations that we can also characterize. Some of the work that we have done around the world that in movement models is that, we can incorporate any modes or preferences, choices, policies. This work was done in Kuala Lumpur, and it was a complete public transportation sandbox. So everything from new efficiencies gained by in first and last mile solutions with bike racks on trains to being able to influence or impact policy and the perception of safety even around transit systems and how that might incent or change the adoption rates. So these are things that we do inside of communities, and then being able to measure. We also work, a lot of our work is in emissions. So we can also measure the impact and that follow through into emissions as well as GDP. Another example, and like I say, we're new to the ports, but these things can be applied, is some work, for example, where we brought together a whole bunch of diverse stakeholders, and we're part of a convergence hub in Washington, D.C. that was inspired by the National Science Foundation with participants from NASA and NOAA and Department of Homeland Security, Department of Energy, where we were actually playing forward very concerning coronal mass ejection events or solar storms, and being able to synthesize and model right down to the ground magnetic disturbances and then the impacts on grid infrastructure for them as they were seeing if they had the right processes in place, data transfer, mitigations from the grid community, and then what the impact of the that would be if there was such an event. So we can play forward events that are really extraordinary, although concerning. I think there was one in Australia just day before yesterday that took out all of the radio bands for a certain amount of time. So even though these scenarios may be extraordinary, they're very important to understand ahead of time in case they happen. We also work with the energy sector quite a bit, so utilities around the US and dial forward scenarios. This work was done with the Electric Power Research Institute, Tennessee Valley Authority, Nashville Electric Service, and the city of Nashville in being able to recreate Nashville along with its infrastructure, built environment, people, resilience centers in complete detail, and then be able to run scenarios of cold snaps, which is ironic that they asked the Canadians to come and do it. But they wanted to be able to map everything from actual grid environments and load curves to all the way through to populations and how they would react or respond, and then how they could mitigate endangerment in those scenarios. We do emergency egress environments as well. So this is something where people are trying to understand how movement, congestion models intersect with different transportation options, ingress and egress. And I'm not sure how this is done, in terms of ports at the moment, but these are all models that we run and help people actually assess which are the appropriate transportation corridors and infrastructure that they may want to put in place. And this one informed some transportation infrastructure in a particular city, and they have since built that infrastructure. I think they had 5 options to choose from. And as decarbonization, the considerations around it are vast. These same models, because we synthesize the populations in these regions, are being used to understand workforce readiness. So to not only engage with communities of educators, of emergency responders, but also to work at understanding certifications and skilling, availability, and even inspire certain communities who may be currently underrepresented in the workforce to participate. So because we can quantify aspects of people and populations and the lives and livelihoods in these connected communities, that plays a role also. So while automation is still very attractive in the poor community to be able to pursue that and remove people from that environment. There is also still a reliance on certain tasks that the communities can be prepared for and engaged in. So for us, it's really playing potentially this connecting role between the communities and the ports, looking at transportation corridors, issues of decarbonization at the ports, providing an environment where we can build this collaboration or consensus so things can be visualized and scenarios can be played through and understood, and then informing that accelerated deployment, so better decisions quicker with more information and insight, as well as responding to some of the more imperative EPA priorities around emissions. So being a participant of the port and the connected community of the port in being able to catalyze that change and communicate that change and participate together in reducing pollution and relaying that information. And there, I think I'm a couple minutes early. So.
Myrna, thank you so very much. So what I would like to do right now, before we go into breakout rooms, there's been people kind of coming and going a little bit, and we are a couple of minutes ahead. So what I'd like to do, Pierre, Sylvain, and Myrna, if you would one at a time, just give a 2-minute short overview of your company again to remind the attendees which room, and then we'll open up the breakout rooms accordingly, and people can just have the conversations. This is the first time we've done this particular way, so for those of you, if you cannot stay on for the breakout rooms, and we will be of course disseminating this information to those who have signed up and not been able to attend, that we really want to use this opportunity to continue on with further conversation. So if you cannot attend after, please reach out to me and we'll be able to connect you to any of the individual companies here. So Pierre, if you want to say a couple of words to just summarize Nuvoola. Up, I'm going to unmute you. Sorry, I had muted you. Hold on. One moment. I see the.
Oh, I unmuted myself.
There we go. Good.
There you go. Yeah, very difficult to summarize, but just we use computer vision as much as possible. And very interesting, and thank you for that information in terms of data is the problem. That is, we see on every type. So working for the Port de Montréal all the way to Vancouver, the data is coming, it's from legacy systems, it's siloed, it's missing, it's incomplete. So we create that data using what a human would do, is using visually recognition to be able to apply that data into your system. So it's really, there's something I often say also when you're dealing with a port, is you get a lot of people that, and if you're in a room and there's 5-6 people that have the same story and they share the story in the ear, and by the time it arrives to the 4th or 5th person, it's a totally different story. It's the fact in every port that we've worked with, everybody wants to shed themselves in the best light, but so there's everything kind of puts a little bit, and that's why we have dwell times that are 7, 8, 10 days as well, is because we're not level setting. And so that's what Nuvoola does, is in certain areas certain times in the process, it level sets with data in real time with digital evidence. It says, your rate is, you're running here and it's got to be done in 48 hours. No, you will not be done in 48 hours. You will be done in 72 hours. And here is the actual digital evidence to go with that. And so apply that. So that's where we insert ourselves within RunWithIt or SimWell. We're agnostic. People don't even know we're taking all this data, we're creating this data, and then we're feeding this different data into different systems. So great presentation, and I'd love to work with you.
Thank you so much, Pierre. Sylvain. Up, let's see. You should be unmuted.
I'll unmute my hair.
Hello.
Yes, very good, Sylvain.
All right, thank you. Yeah, so SimWell, what we do, we build simulation models, but what they are really, it's tools. It's tool much more powerful than in the past. In the past, we use Excel spreadsheet, graphs. We sit down. Nowadays, computers are very, very powerful, and they allow you to do what you would do with a handful of people. You can actually do very, very much more effectively. And and at the end of the day, by connecting all of those tools together, you can have better solutions for all. The one thing I'd like to add as well to the last presentation is, when we're talking about data and connecting data, the one thing that I didn't mention in my presentation is there's a way that you can actually run a top level model that goes and runs somebody's model to understand the impact on them without having access to their corporate knowledge and their system. So all that is important is to feed another model. The answer comes back. It's the answer that's important, not so much everything that happens. So it's not as if we're going to start sharing secrets and we're going to be a big old happy family, because I understand the importance of segregating data as well. So thank you very much.
Excellent comment as well. And Myrna, if you want to do a short wrap up as well.
Sure. Yes, I would enjoy working with both of these companies. We again are that one step, kind of into the strategic and engagement process, where those larger scenarios that involve policies and technologies and events or special considerations, a lot of resilience environments, or even connecting to onshore sectors and concerns can be played out and oftentimes more efficiently. Just as Sylvain and others were saying, there's this efficiency gain when we can capture and use that data very quickly. There is an efficiency gain in bringing diverse stakeholders together as well, and being able to agree on what we can see and express in future scenarios. So it's part of that strategic efficiency and optimization also that we are engaged with in our simulation environments.
Thanks so much. And again, for everybody that'd be listening, obviously all of these solutions are not only for the port environment. We put a lens around on the ports, but we also know, of course, there's so many different stakeholders that we look at Braid Theory to support the port ecosystem. So it can be all the way through from the truck companies to the warehousing, to the terminal operators, to the communities that are adjacent to the ports and to the cities, to broader port-to-port initiatives like Sylvain was talking about. So, and a lot of these solutions, as Sylvain mentioned, are applicable in other industry sectors. One of the things that we were tasked at Braid Theory was to help get better understanding of the port ecosystem, because some of these companies have much more robust experience in other industry sectors. So to even allow us to bring some of the opportunities and challenges in and around ports to these teams is one of the things that Braid Theory does for a living. And one last shameless plug is, please save the date for May 2nd. Our event, Ignite 22, the Global Tech Showcase, will be held at AltaSea at the Port of Los Angeles on May 2nd. It's a full day event of show and tell, demos, exhibits, things splashing in the water, 400 to 500 people. We expect to have approximately 100 innovative companies like the 3 that are presenting today. And so I hope you will put that on your calendar. And if you have any questions about that, see me another time or reach out to me. And I'm now going to go ahead and open up the rooms, and we'll keep them open for the next half hour so you can kind of go back and forth and to have answer any questions that you might have. Thanks so much.
Very good. Thank you.
Okay, so everybody should be able to now move into, I'm going to stop recording.